Okay, so we are given two points that are the endpoints of the diameter of a circle. So I've drawn a circle and I've marked 2 points. The first thing we want to do is we want to find the center of the circle. So we're looking for, well, that's not the center. Well, that's not either, but I'm getting approximately there. We are looking for the center of the circle. So let's see if we can't find the center of the circle, and just ignore my picture. It's not perfect. Okay, so to do this, the center is going to be the midpoint. So remember, the midpoint formula tells you to add the two x's together, divide by 2. Add the two y's together, and divide by 2. So what does that give us for our problem? So the x's are 3. We're going to add that to -1, and we'll divide that by 2 in a second. For the y's, we have a -6. We're going to add that to 2, divide by 2. So 3 plus -1 is 2. -6 plus 2 is -4. So it looks like the center of our circle is 1, -2. So I could put that up here. Whoops. Yeah. 1, -2 is our center. Now, the next thing we want to find is the radius. So the radius is going to be the distance between the center and one of these endpoints. So I'm going to use, let's see here, I think I'll go ahead and use this endpoint. And of course I'm going to use my center, and those are going to be the 2 points I use to get my radius. Now, of course, it's going to be a distance. So the radius, we're going to use the distance formula. The distance formula tells me to take the square root, I'll remind you of the formula, difference in the x's squared, plus the difference in the y's, and that also gets squared. So we are using the points I've highlighted, or circled actually. So I'm going to do 1 minus -1, that gets squared. For the y's, I have -2 minus 2, that will also get squared. So just be careful with your signs. 1 minus -1, that becomes a plus, so that becomes a 2 squared. -2 minus 2 becomes a -4, that gets squared. When you square 2, 2 times 2 is 4. When you square -4, -4 times -4 is positive 16, so we end up with the square root of 20. Now technically we should simplify this. 20 has a perfect square that goes into it, which is 4. The square root of 4 is 2. So this would be the correct simplified answer, would be 2 radical 5. Now we want the equation of the circle. So let me just remind you of the equation of the circle. It's x minus h squared plus y minus k squared equals radius squared. Now remember, h and k come from the center, so let's just do this. Let me do this right here. So the center is hk, which for our problem just a moment ago we found out center was 1, -2. So that's what h and k are. The radius is 2 radical 5, or we can use square root of 20. That'll actually be a little bit easier in just a minute. So we're going to take these two and plug it into the formula. So I get x minus 1, h is 1, plus y minus, I won't skip any steps here, y minus -2 equals, for the radius I'm going to use square root of 20 because we have to square it. So final answer, x minus 1 squared plus y plus 2 squared equals 20. So if I wanted to write that here, I could. X minus 1 squared plus y plus 2 squared equals 20. Okay, let's move on to the next one. On the next one, I just have given you an equation, and we want to start by finding the intercepts, and we want to test for symmetry. So the first one we're going to find is the x-intercept. Remember, on the x-axis, y value is 0. So here's the equation we get. 4x squared plus 0 equals 4. Well, of course, that left-hand side is the same as 4x squared equals 4. I'm going to divide both sides by 4. That reduces to 1, so we get x squared equals 1. Now, I've said it lots of times. To finish this, we need to take the square root, but there is nothing, there's nothing that tells us that x has to be positive, so we need to look at both roots. So the two answers we get here are positive 1 and negative 1. I prefer to write them as ordered pairs, so I'm going to write them as 1, 0 and negative 1, 0. Okay, so two x-intercepts. Y-intercepts are often easier. For functions, they're for sure easier. But for y-intercepts, you let x be equal to 0. So if we take that equation, we're going to get 4 times 0 squared plus y equals 4. Well, 0 squared is just 0, 4 times 0 is 0, so we end up with just 0 plus y equals 4, or y equals 4. Again, I like to write these as ordered pairs, so as an ordered pair, the y-intercept is 0, 4. Okay, now we do our test for symmetry. I'm going to start out with x-axis symmetry. Remember, there are 3 different tests. For x-axis symmetry, you take the equation, in place of y, you put negative y. You are going to do any simplifying you can, which in this case, because we're adding negative y, we can just write that as 4x squared minus y. If you get the same equation, the original equation, it has x-axis symmetry. In this case, we have this minus here. That was not in the original equation. So we did not get back to the same equation, so this does not have x-axis symmetry. So now we're going to move on to y-axis symmetry. For y-axis symmetry, you replace x with negative x. Again, you want to simplify. When we square negative x, it is the same as x squared. The negative times the negative becomes a positive. So notice what just happened here. We did end up with the exact same equation that we started with. So it definitely does have y-axis symmetry. Now, origin, we talked about in class that it couldn't actually have 2 types of symmetry. It could have none, 1, or all 3. So I know this answer is going to be no, but let me show you the test. You replace x with negative x, and you replace y with negative y. We've done all the simplifying. We know negative x squared, when you square a negative, it becomes positive, so that becomes positive 4x squared. We know adding negative y is the same as subtracting y. So this is the equation we end up with. Notice again, that negative is not in the original equation, so we do not have origin symmetry. So the only type of symmetry this equation happens to have is it happens to be symmetric to the y-axis. Okay, let's look at some lines here. We want the line passing through 2, 5 and negative 2, 3. The first thing, or one thing you need for pretty much every line, other than vertical lines, is slope. So the first thing I'm going to do is I'm going to find slope. Now remember, slope is rise over run, so it's difference in y's over difference in x's. So I'm going to do 3 minus 5, that's the difference in the y's. For the x's, I get negative 2 minus 2. 3 minus 5 is negative 2. Negative 2 minus 2 is negative 4. Of course, those two negatives become positive, and this reduces to 1/2. So what this tells me is now I have, this is what I know. I know the equation is y equals 1/2 x plus b. I do not know b. You can choose either point you want to at this point to find b. Just because I don't like the negative in the second point, I'm going to use the point 2,5 when I do this. I'm going to replace y with 5. I'm going to replace x with 2. And that'll be enough information to solve b. Notice the 2's cancel, and I'm left with 5 equals 1 plus b. So when I subtract 1 from both sides, I get 4 equals b. So putting this all together, we get y is 1/2 x plus 4. You can put that up here if you want me to. 1/2 x plus 4. Okay, first one is done. Now we want a line that is perpendicular to the line in part A. So I'm going to just start with that. In part A, remember, the slope was 1/2. Our line is going to be perpendicular to this. Now this tends to be where students struggle with lines, is when they are looking for perpendicular slope. Remember, we need to turn the 1/2 upside down, or invert the 1/2, which gives us a 2, and we need to make it negative. So our equation is y equals minus 2x plus b. That's what this leads us to, is this equation right here. Now, the second part of this problem, which I haven't even read yet, says we want the same y-intercept. Well, if I go back up to the previous equation, I see the y-intercept was 4. So if I just take that information, notice the y-intercept was the only thing I was missing, so the equation becomes minus 2x, and we're told the same y-intercept, so that's going to be a 4. So the line we're talking about is minus 2x plus 4. Notice the two answers both have a y-intercept of 4, so they have the same, they have the same y-intercept. Now look at their slopes. This is important. One is 1/2, one is negative 2. Those are negative reciprocals, so we are good to go. Okay, here is my favorite kind of problem. This is the easiest one there is. Let me draw a little bit of, Let me draw a little bit of a picture here. So first of all, I'm going to graph negative 2, negative 3. I don't want to spend a lot of time doing this, but there's negative 2, negative 3 approximately. I also want to graph the line y equals 5. And again, 1, 2, 3, 4, 5. I didn't give myself a lot of space, but y equals 5 is up here. We want to be perpendicular to this line, which means we need a vertical line. So we want a line that goes through negative 2, negative 3, but is perpendicular to y equals 5. So this is the line we're talking about. It's clearly vertical. Every point on that line has the same x value. If it goes through the point negative 2, negative 3, the x value must be negative 2. So what that tells me is my line is x equals negative 2. Okay, the picture is helpful. On quite a few of the homeworks, some of you worked with the horizontal and vertical beautifully, except for you got them mixed up. If you will draw a picture, you can clearly look at this line and see, okay, no matter which point I pick on this line, the x value is negative 2, so clearly the equation is x equals negative 2.